The next example plot I'm going to talk about is a bar plot. Here I'm using the default bar plot function, which is built into R, and I'm supplying its first argument is m. Those are the 4 means that I already calculated, so I would like to plot those 4 means as a bar plot. And I'm only supplying 2 other arguments right now. That is the ylab, just a string wags will appear on the y-axis as a label. That's just cosmetic, and the range of the y-axis from 0 to 35. So that's what that looks like. This is the same information that we just plotted. Well, it's a lot less information, but it represents the same relationship between variables. So these are just the 4 means in each of these 4 groups.
So I know that you labeled each of these factors and that it is the 1 through 4 has split it alphabetically. How would you go about if you didn't want it displayed in alphabetical order, but you still wanted to keep the same label names?
So the reason, yeah, that's a good question. The reason, I'm going to go back to the box plot. That's this line of code up here. And it plotted them in alphabetical order. The reason it did that is the type variable is, well, actually, the type variable is a factor, and it has these 4 levels. And by default, R will consider those levels as being in alphabetical order. You can change the order of the levels of a factor in order to change how R will treat that factor for all sorts of stuff. And then R would plot it in whatever order the factor is represented in. But also, if you didn't want to go messing with the factor, you could yeah, so a lot of the things that are coming to my head are maybe a little overcomplicated. Probably changing the order of the factor levels is going to be the easiest way to do it. I mean, you could do things like plot so this box plot command really generated 4 box plots for each of these subsets. You could plot them one at a time, adding them to the same plot in any order you wanted to, but it might actually be easier just to change the order of the factor levels.
Sarah.
Yeah.
So the way that I have done it before is, so I did this for one of my race variables. So I did like data $race equals factor, and then put the data $race again, comma levels equals C, and then put them in the order that you want with like quotes around it. So I did that, and then it
Oh yeah, when you create the factor, you can probably specify the order. Yeah, perfect.
So
Okay,
like,
so
it wasn't like that originally, but then at the end I did that, so it was like in this order.
so if I have a string variable x, that's a, b, c, and just to clarify, x could have as many instances of these as I want, right? It could be a, b, c, c, c. Then what Ellie's saying is I can, for example, turn x into a factor like this, or even give the factor a different name like xf for factor. I can supply another argument to the factor function that specifies that I want the levels to be, say, C and then B and then A. And that, perfect, yes. So X is still A, B, C, 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 the way it was supposed to be, but the levels are in the order C, B, A. That is what you would want to do if you wanted to have the default box plot function plot them in a different order without having to mess around with more complicated plotting stuff than just this kind of a function call, because it would use the correct factor order.
That's great. Thank you.
No problem. I learned something too. That's great. So what were we doing? Oh yeah. Here's the basic bar plot function. If I wanted to add standard error bars to the bar plot, I'm going to need to figure out the location of those bars along the y-axis, along the x-axis, and it turns out R does not by default consider those to be 1, 2, 3, and 4 like it did for the box plot. Those are actually 0.7, 1.9, 3.1, and 4.3 like I have represented here. The reason is that the default spacing of the bars is 0.2. You can change the spacing when you call bar plot. So I can show that by looking at the documentation for that function. The space argument is null by default, but if you leave it that way, then in the way that I'm calling it right now, it will default to 0.2. And because it defaults to 0.2, it's like this white space that's to the left of the Basenji bar, in between the axis and the start of the bar, is 0.2, and then the middle of the bar is an additional 0.5 units along the axis after the 0.2, because the whole bar is 1 point wide. And if I want to put my standard error bars in the middle of these bars, then I want them to be located, the first one to be located at 0.7, which will be the middle of that Basenji bar, because the bar is 1 unit wide, and it begins 0.2 units from the 0 point on the axis. The next one falls at 1.9 by the same logic. So after 0.7, if I add the other 0.5 to finish up the Basenji bar, I would be at 1.2, but then the space in between the Basenji and the Beagle bar is another 0.2, so that's 1.4, and then I want the error bar for the Beagle bar to be in the middle of the bar, so I would add another 0.5 to that and end up with 1.9, and so forth to get the rest of these. You don't have to be able to calculate where the middles of these bars are off the top of your head each time. You can, of course, just use trial and error by trying some estimates and seeing if the resulting plot has the bars in the middle. Anyway, that's why I created this variable called x-coords first that just remembers for me what those 4 positions are supposed to be. Then I'm going to use a loop to add my error bars again by calling the lines function 4 times, just like I did for the box plot, with the means plotted as circular points. And so this is very similar logic to what I did back there. The first argument to the lines function is going to repeat the corresponding x-coordinate value twice. So x-coords is a vector with 4 values. X-coords square bracket I will retrieve the ith one, whichever one we're currently working with as we're looping through these 4 possible values. And it's going to repeat that twice because I want the line to start and end at that x-coordinate. I don't want these lines to be diagonal. I want them to be perfectly vertical. So start and end at the same x-coordinate. The y-coordinates for the lines are going to be the corresponding mean minus the corresponding standard error and the corresponding mean plus the corresponding standard error. So this will plot, call the lines function 4 times and plot all 4 lines, each of them with the x-coordinate at 0.7, and then 1.9, and then 3.1, and then 4.3, and the y-coordinates defined by the means and standard errors. So now there is the result of calling the lines function 4 times like that. Given that this bar plot from up here already it was the active plot, these lines got added to that active plot, and they represent the standard error of each of these means. 1 standard error above and below the mean. If you don't want to deal with the weird x-coordinates due to the spacing between the bars, one thing you can do is call bar plot with 0 spacing. So this is the same bar plot with the y-lab and the y-lim specified. I added 1 argument in between those. I don't know why I put it in between them. Sorry about that. But this is the only new argument, space equals 0. So this calls that bar plot again, but now there's no space in between the bars. And I'm going to add those lines. And this time, the x-coordinate is just I minus 0.5 repeated twice, I being 1, 2, 3, 4, because I want the bars to appear, the error bars to appear in the middle of the bars rather than at the end of them. So the Basenji bar starts at 0 and ends at 1. So the error bar should be printed at 0.5 along the x-axis.